Hey guys, welcome back. So today we'll be making the prime spiral. So let me go to the whiteboard. Let me show you what it is. So there we go. All right. So the prime numbers, right? We all know them. It's numbers, whole numbers that are only divisible by themselves and one. And one is not included in those. So we start 2, and then we have 3, 5, 7, 9, so on and so forth, right? So um, we first need to get a list of prime numbers. We can calculate it pretty easily, not the best way, but let's just do it a way for the moment. I mean, you might want to improve this. You could, yeah. So well, anyway, let's do it. So right, we'll have some kind of list of integer, right? Um, so some kind of array of integers. This might be, yeah, this is a bit small. So right, so we have an array of integers, right? Into that array, we can just do a for loop, right? And we can just arbitrarily set some kind of numbers, right? So from 2 to maybe, I don't know, maybe, and let's set by default that, let's say by default that 2 is in there, right? So we can say that we go from like 3 to maybe, I don't know, let's say 100 for right now. We can always change that number, but yeah. Okay, so um, yeah, let's do I. Okay, all right. So we can just check if, and we can do jumps of 2, right? So we can go from 3, only do odd numbers because we know all even numbers are going to be divisible by 2, right? So they won't be prime numbers apart from 2. But let's not care about it. So let's just say if I is well, the modulus I modulus the rest of division. So I divided by something rest is like whole division. The rest will be so let's see. We can do I, and then what I would say is, let's erase what I just wrote. We can just do another for loop, right? That goes for each number, uh, each number in prime. So primes would be this, right? This is prime. All right. So for each number in primes, we can check. We can have some variables before this, right? So over here, we can have like, um, or we can just say, let's do this. We could just say if I is uh, wholly divisible by the number, then we can just continue and go to the next number I, right? Otherwise, if that whole loop is completed, that means we did find a prime number. So we can just say, we can just add the prime, add I to the primes, the list of primes, right? So that's an easy way to do it. It's definitely not the most efficient way. You can always, like I said here, you can only check odd numbers. On top of that, you could stop this iteration whenever number is greater than the square root of I. There's probably more option for optimizing this, but in any case, this is it, right? So now let's say we have our list of primes here. We can just, so let's say we only have like a whole number from 1 to 100, right? We know that to draw a circle, we need the middle point, right? So let's call it center, which is xy, okay? And we need basically to draw points around that center and then connect those points, right? So, and to get each of those points, we need the angle for that specific point, right? So we also need an angle that changes, right? So let's take, and then you can do, to get the x and y, let's say of this point, maybe the angle in this case is, let's say, maybe 45 degree, right? So 45 degrees, right? So this would be a point at 45 degrees. So we could say we want, so x for that point would be the cos of 45 degree. And then to get that specific length from the center, you just multiply by the radius. That's pretty much it. You don't need the center, never mind. And for the y, you do exactly the same thing, but instead of cos, you use sin. So sin of 45 degree times radius, right? And you would get that other point, right? What if, while going through every angle, let's say, what if we were to also make this value get bigger, right? So to begin with, it would be really close, let's say. Let's say radius to begin with is 0. So it's on top of this point, right? And then as the angle grows during the loop, right? During the time we iterate through all of the angle, we just make the radius go a little bit bigger, right? And a little bit bigger. And so at that angle, it's really close, then it's getting a little bit further and a little bit further, and so on and so forth, right? So we would get some kind of spiral, right? So that's basically the goal. Now, what we're going to say is that we're going to say that any given radius will be the prime number, right? So r will be prime. So as we go through the primes, it's going to get bigger, and then the angle will also be based on the prime number, right? So the angle, we can say, we can set the angle mode to 360, and then just loop through the pi's using the angle. So that's pretty much it. Let's get into it. All right, so let's make let's just make the pi's, right? The prime value, sorry. So we'll have an array list of integers, call it primes. It's going to be a new array list of, well, it doesn't matter, okay, of integers. Okay, awesome. And then we can already set those values. What's the issue here? Error on dimension. Array list of ints. New array list of ints. What's the issue here? I don't know. Let's continue. It doesn't matter. So let's say we want to go from int top, right? So let's say we want up to the prime 10,000, right? So we need to loop from, we said to add 2 already in there. So let's do that. So primes.add, because we know we're starting at 2, so and that's fine. Okay, and then let's do for int I is equal to 3, starting at 3. As long as I is less than the top, and we could say less than or equal, it doesn't really matter. Oh, and that's a reserved keyword. Let me use lowercase top, should be fine. Anyway, okay. I plus equal to, right, because like I said, I'm just going to do skip the even numbers, right? So we said at the end of that loop, if we didn't continue to the next one, we can just add I to the primes, right? So that's it. And then we can do another for loop inside of here where we iterate through the primes, right? So we could say int p for prime of primes. Then we check if I modulus prime p is equal to 0. That would mean that it is divisible by that prime number. So we just want to continue the loop without going here. That's basically it. And we could also say if the square root of I, if p is greater than the square root of I, just add I into it and skip, but it doesn't matter. Let's not be efficient right now. All right, so we've got our list of prime numbers right now. Let me print out that list just to make sure it's actually what we expect it to be. I might have done some error. I really don't know. Let's see. So let's just do print ln prime, or p in this case. Okay. I'm not sure if I can start this just without void, or what's the issue here? Error. Insert dimension to complete reference type. I don't know what that means. I have no clue what's the issue here. Well, you know what? Let me do something else then. Well, can I do this? Okay, no, it's not giving me any issues. All right, awesome. So let's close this and let's take a look at this, right? If p is smaller than 100, right? Doesn't need to go up to the full list. Okay, that's fine. Let's see it. So I know it's a bit small, but we have 2, 3, 5, 7, 9, 11, 13. That's not right. 15 is divisible by 5, so there's an issue over here. What's the issue exactly? If let's say 15 modulus should go up to 5, right? Because 5 should already be in there. Is equal to 0, then continue. I mean, it should have gone here. Oh, maybe it doesn't continue. It continues for this one, right? Let's do something else. Let's do a boolean called not prime equals to false. And let's say when this is the case, let's say not prime is equal to true. And let's break. I would assume it only breaks from this loop, since continue only continues for that loop. And then let's say if not prime, continue. All right. right? Should be fine. Okay, so let's see this. 11, 13, now we don't have 15, 17, 19, that makes sense, 23, yeah, that looks good, that looks fine. Okay, so we have all of our prime numbers, right? Awesome. So now, let's do it. It should be pretty quick to do. So, we have setup, let's do size of like 800 by 800, that should be fine. And let's do a background of, I don't know, of maybe 33. Let's do the stroke being 255, so white. Let's do stroke weight of, I don't know, let's say 3, just so that's a bit visible, maybe 2, we'll see. And then let's just go through all of our primes, right? So, well, let me rewrite it, it's fine, it's not that long. Int p of primes. All right, now we need to calculate the x and y, right? So I'm going to first translate everything to the center. All right. And do I need anything? I don't think so. All right, and let's set the angle mode. Oh, well, cost is not going to be affected by this, right? So, we could possibly just rotate. Sure. I mean, no. Well, and I'll do it 2 ways, right? The first and easy way to do it would be to just do, sorry, like int or float a or angle is equal to map of from of the p of the prime that goes prime, let's say from 0 to 360 to 0 to 2 pi. I don't like that solution. Let's just do angle mode. Is it that? I don't know. Degrees. I don't know if it's angle mode. Let's take a look at the references. Okay. Angle mode. Mode. Shapes. No. Rec mode. Angle. Rotate. Let's take a look at rotate. It might talk about it. Pi divided by 3. Okay. Okay, let's just use the radian function then. That's fine. Okay. All right. So rotate. Push matrix. Rotate by p. Oh, and let's change this to radians with an S, radians. All right. And then let's do float x is equal to the cos of the angle, which we have here. Let's call it a, times, and here is p, right? So we want the angle and the distance between the center of the circle, well, the spiral, to be based off of the prime number, right? And then let's do y, which should just be the same thing, but the sign. Okay, awesome. And then let's do a point at that xy value. Okay, and then let's do pop matrix, right? That we don't need to rotate in this case. I forgot. Okay, awesome. Okay, setup. What's the issue here? Missing semicolon near setup. Am I? I don't think I am though. Oh yeah, this. Okay, what else? What else? Where is my missing semicolon? I don't know. Where is it? Void setup, curly brace. All of that makes sense to me. I'm not missing any. Is it break that doesn't require it? No, break does require it. What's the issue? Is it? No, that can be. Let me rewrite that line and see. Void setup. What if I were to move all of this into the setup? Would that solve the issue? Seemed like it did. I don't know. It doesn't matter. Let's try it. All right. So we're pretty much done, I guess. Let's maybe scale it back a little. Let's take a look at the scale. Not here. Scale. Can we do scale 0.5? Okay, awesome. Let's do scale 0.3, maybe. We'll see. Oh, and I might want to scale after the translation. Okay, I think it's good. Let's maybe up the stroke weight. That's good. Looking good. All right, so let's do stroke weight of 20 and let's do 0.1. Okay, we're starting to see the pattern, right? So let's do 50 and let's scale it really a lot. Okay, maybe 50 isn't even enough, right? Let's do 100. Okay, good, awesome, that's good. Let's up the amount of the top number prime we can have. Oh, there you go, that's cool. So that's pretty much the whole sketch. Maybe adding some color, maybe changing the hue. Using the prime value, right, could be fun. Well, let's try it out. So here, stroke, we'll put it in here, and we'll say color mode. Well, let's call color mode after setting the background. Color mode to HSL, I believe. Right? No, so U, saturation, luminance. U, luminance, saturation. No, U, saturation, brightness, not luminance. Yeah, I mean, whatever, it's fine. Okay, so let's do P modulus 360, right? 255, sorry, 255. Okay, well, I don't know. We could do regular for loop, maybe a bit easier to do it with that, right? So I0, I is less than primes dot size, I plus plus, and then let's use I here, and let's say int p is equal to primes dot get I, right? We can do this. Okay, let's see it. Okay. Um, doesn't seem like the colors are really there. Maybe make the stroke rate really big. Okay, I think I get it, right? So this is considered just gray, right? Because I only passed one argument, so I need to pass HSB altogether. Let's do saturation of this, and brightness, let's do the full brightness. There you go, awesome. So again, a bit, a bit funny. We can try it with P as well, just to see what we get, right? So P instead of I, let's see, right? So it's different variation. I mean, there's so many possibilities, right? And if we go far enough, right? So let's say 0.101, right? That's really ginormous. Let's do 500 the weight. It's really big, but let's see it. Okay, okay. I mean, we're seeing them a little bit. Let's do 1,000. It's just okay. That's good. That's good enough. And let's do maybe up to 1 million, right? 1 million. It may take a little bit of time just to calculate that many prime numbers, or up to that number for prime. There you go. So you see, we really started with a spiral, but now we're able to see like actual delimitation, like lines. It's pretty cool. Yeah, so have fun with it. Hope you enjoyed the video. If you did, make sure to like. See you in the next one. Thank you.